In this video, we will introduce and discuss natural frequency analysis. First, let us discuss the fundamental concepts. The natural frequency, denoted as omega sub n, is the rate that an object vibrates at when it is disturbed. Objects have multiple natural frequencies. If the loads applied to the object excite any of its natural frequencies, the motion may become uncontrollable, and the component may fail. So let's look at some examples where we might need to know the natural frequencies of an object. Knowing the natural frequencies is critical to the design of engines. For rotating equipment, we not only need to know the natural frequencies of the rotating machine, we also need to know the natural frequencies of the structure that the machine is attached to. While electric components don't have moving parts, vibrations from machinery can excite the natural frequency of electronic components and lead to premature failures. Let's consider a 1 mm diameter wire. If we fix one end of the wire and move the free end from side to side, we can change the shape of the wire. As we increase the speed that we move the wire back and forth, we can create more bends in the wire. We are exciting the natural frequencies of the wire. We can use 3DEXPERIENCE to predict the natural frequencies of the wire, or any other structure. All we need to do is select a frequency step, and specify the number of frequencies. After solving the model, we can plot the deformation using the animation app to see the natural frequencies, and their shapes. The modes are ordered from lowest to highest frequency. Using the animation, we can see that the first three modes are simply rigid body rotations. For product design, these are not a concern. We can see that the fourth and fifth modes have the same shape but are orthogonal to each other. This is because the wire has a circular cross-section, and it will behave the same if we either move the wire from side to side, or up and down. When designing structural parts, it is important to know these frequencies. While we most often try to avoid the natural frequencies, sometimes we exploit them.